Hi, in this video I'm going to explain how to apply this concept of conic section that we have been learning in the past weeks, how to apply this to real life situations. So let's start by this case right away. It says the seismological service has detected an earthquake epicenter near a city. The epicenter was located 5 kilometers to the east and 3 kilometers to the south, and it was estimated that the earthquake will reach a radius of 5 kilometers around, which is the equation of the circumference of the affected area. Also determine if the city was affected by the earthquake. So first, let's say, as we can see, there's no origin explicitly stated, so we can pick the origin to our convenience. So I'm just going to say the simplest case would be just to pick the origin to be at 0, 0. I'm going to use here on the right this grapher to show you what I'm going to be doing. So the center, which will be in this case the city, will be located on the origin here, 0, 0. So this green dot represents the city. Now, it says that the epicenter of this earthquake was located 5 kilometers to the east and 3 kilometers to the south. Now, according to what we just stated, the origin will be in 0, 0. That is to say, from the city, the epicenter will be located 5 kilometers to the right, because that will be east on the right, and then 3 kilometers to the south, that will be below the x-axis, so it will be -3 kilometers, in this case -3. So here we have green would be the city, and purple would be the epicenter of the earthquake. Now it says here it will reach a radius of 5 kilometers squared. So we can use a super cool formula for the equation of the circumference. We have here is x, which is a very ugly one, would be x minus 5. Here will be the h, will be the x component of the epicenter of the earthquake. Will be here y minus, this will be -3, would be +3, would be squared, and there will be the radius squared, which will be 5 squared. So in other words, here we have 25 equal to 25. So let's see here. I'm going to write here the equation using here the decimals will be x minus 5 squared plus y plus 3 squared will be equal to 25. And there is our, this is the earthquake, will be representing the earthquake and how it will reach to which extension. As we can see from the graph, we can literally see that it's not going to reach the city, at least, or at least the city center in this case. It's not going to be reaching it, so pretty much that would be it for the first question. Now determining if the affected area of the earthquake, the city will be affected by the earthquake, but well, in this case it won't. Now let's try to, we can see it from the graph, but let's try to do it in a more sophisticated way as well, just to find out at least a couple of more ways to find out if the city will be affected, right? So first I'm going to use another formula. I'm going to use a formula, it's called, it's like this, distance is the formula for distance between points. So it will be here x2 minus x sub 1, which will be squared, plus y sub 2 minus y sub 1 squared. This is the distance between 2 points. Now, if I calculate the distance, let's say I have here would be the city, it's located at 0, 0, and you can see, let's use this purple, and I'm going to use this one. The epicenter, it's located at 5, -3. Now we know the radius of this earthquake is 5 kilometers. So if we take the difference, I mean the distance between the city and the epicenter, and it's bigger than 5, then we can verify as well that this city won't be affected by this earthquake. So let's work this through here. Would be distance would be equal to x sub 2 minus x sub 1. You can pick any order. So it's going to say 1 minus 5 squared plus let's say here will be 0, will be minus, sorry, minus 3 squared. This is all squared, so we have this squared This looks better. There it is. So this distance will be equal to the square root of 25. Negative 5 squared will be 25. We here plus 9. Plus 9. So this distance will be equal to the square root of 34. Now the square root of 24 is clearly above 5. So I'm just going to get the exact value. Would be equal to 5.83. This distance would be equal to 5.83. In this case would be kilometers. So as we can see, this 5.83 will be bigger than the radius of the earthquake. So it is, in other words, it's another way to verify that the city was not affected. Now I'm going to try to do this in another way, a third way, just to show you what else can we work through with this original equation. So these equations, if you input a value for x and y that suffice this with the radius equals to 25, you will get values for example, like this one on the right, 5,2. If you input here on the function 5 and 2, I'm going to just do it quickly to show you. I'm going to use better off this blue color. I'm going to pick the square. This is the y. Will be here plus 3. Here will be negative 5. So if I pick this coordinate 5, 2 and place it in here 5 and 2, we get here in return this will cancel out. It will be 5 minus 5 0. 2 plus 3 will be 5. 5 squared will be equal to 25. So what I'm trying to say, if I pick any point, for example, this one 1, 0, if I pick any point in here that's this a coordinate, it's a coordinate of this circumference, and if I substitute it in this equation, I will always get in return this 25 equal to 25. Now what happens if I instead of picking a point such as this one, I pick another point? For example, let's say I pick the point 4, 0. Yeah, 4, 0. So 4, 0, if I pick, let's say, I'm going to work in here, x minus, I'm going to write here just the numbers missing, just there it is, equal to 25. So if I pick a number, let's say I'm going to pick here 4, 0 will be around here, 4, 0. So let's see, will be here a 4 and 0. So here 4 minus 5 will be negative 1 squared. I'm going to use here negative 1 squared, and here will be 3 squared will be 9, will be equal to 25. And we can see here will be 1 plus, this will be negative 1 squared will be 1 plus 9 will be 10, which is obviously not equal to 25. It's below, it's lesser than 25. The thing is, actually, if you pick any value of the circumference that it's within the radius of within the area of the circle, you will always get in return a number that will be smaller than this 25 in this case. So what will happen if you pick a number that's outside of the area of the circle? For example, here the origin or where the city is located. You could say, well, let's try it out. So let's try what we see. I'm pretty sure you can infer what's going to happen. So if I pick, I'm going to substitute here the 0, 0, here negative 5. I'm going to use orange. Say orange 0 and 0. So this represents the coordinate of the city. So in return, I will get here negative 5 squared will be 25 plus 3 squared will be 9 equal to 24. And as we can see, this will be equal to 34, which is greater than 25. So in other words, If you pick any number, any coordinate that's outside of the area of the circle, you will always get a value that's bigger than the right side of the equation. So that's another way to verify, to answer to these questions. We can see we found 3 different ways to using the graph, using the distance between points, and using this equation for the circle just to verify that the city after the earthquake, well, was safe, or will be safe.